Hello, and welcome to Beyond Thinking, where we share and discuss about space exploration and humankind. Join us and keep watching. But first, if you like this content, consider liking and subscribing to hear more about Beyond Thinking. The El Nino climate cycle is the topic of today's video. There are many cyclical variations in life on Earth, day and night, the ebb and flow of the tides, the changing of the seasons, and so on. Many of these changes may be precisely predicted and occur over relatively brief times. Other cycles, however, have longer timescales and therefore be more difficult to predict. The El Nino Southern Oscillation, or ENSO, often known as El Nino and La Niña, is one climate cycle that unquestionably has an impact on mankind. El Nino Southern Oscillation. While El Nino and La Niña have their origins in the Pacific Ocean, their effects may be seen almost everywhere on the planet. According to some reports, the strongest effects are becoming more frequent. In recent years, some of the harmful effects have included flooding, drought, starvation, and major extinctions of marine life. In fact, a severe El Nino in 1998 led to the estimated 16% death of the world's coral reefs, sparking a devastating mass bleaching event that continues to this day. Everyone will be impacted by the ENSO because it is a global phenomenon. Fishermen observed periods of warmer water and poor fishing during the 17th century, which peaked around Christmas. It wasn't until the late 19th and early 20th centuries that scientists started to link a range of disconnected regional rituals strewn around the Earth. They termed it El Niño de la Navidad, which translates as the Christmas child. By the middle of the 20th century, it was discovered that these localized occurrences represent stages of a larger cyclical phenomena known as the El Niño Southern Oscillation. The ENSO cycle lasts from 2 and 7 years. However, the average period between fluctuations is 5 years. Upwelling impact in the Pacific Ocean, normal cycle. East to west winds flow around the equator. It is a byproduct of the Coriolis effect, which is brought on by the rotation of the Earth. If the Earth didn't revolve, air would flow north to south from the cold, high-pressure poles to the warm, low-pressure zone near the equator. Actually, air does move away from the poles, but it curves as it gets closer to the equator. Air in the northern hemisphere deflects to the southwest, while air in the southern hemisphere deflects to the northwest in a circular band that stretches 30 degrees north and south of the equator and is frequently referred to as the horse latitudes. The trade winds were the name given to this air current that is traveling west. They pull warm water from coastal South America into Asia as the wind travels west over the Pacific Ocean. Upwelling is the process by which cooler water rises to replace this warm water as it flows west. The phytoplankton in this chilly water is nourished by the nutrients, which supports ecosystems of fish and everything else that depends on them. Therefore, as you might expect, a shock to the system would have significant cascading impacts on marine life. If this is how the Pacific Ocean normally behaves, then El Nino is a deviation from normal. Global impact of El Nino. El Nino causes the trade winds to diminish, which causes warm water that would normally flow toward Asia to build up along the coastal Americas instead. This causes less cold water to upwell. As a result, the Pacific Ocean further east develops a zone of warm air and water. The fish that consume the phytoplankton migrate or perish when there is less upwelling. The North American portion of the Pacific jet stream shifts southward from its usual direction. The Gulf Coast and significant portions of coastal Southwest America experience wetter conditions as a result, while the northern United States and Canada tend to become warmer and drier. The wettest months for Peru and Ecuador are from April to October, and during more extreme El Nino years, flooding and heavy rains there can be disastrous. Due to the terrible floods brought on by the extreme El Nino in 1997 to 1998 in Peru, 250,000 people lost their houses. The normally dry region of Tumbes experienced an incredible 16 times its annual average rainfall. El Nino outside of America causes a chain reaction of events that drastically modifies the weather all around the planet. Typically, a severe drought in South Asia and Australia occurs at the same time as an increase in rainfall in South America. India has had severe famines, while a postponement of Australia's monsoon season can result in extremely devastating bushfires. There are already worries about an occurrence that might take place later in 2023 due to Australia's bushfires, which are among the most destructive on Earth. Given recent trends in global warming, leaders' concerns are understandable. Global impact of La Niña. The El Niño Southern Oscillation has a counterpart called La Niña. La Niña is a chilly event, although some locations do experience warming if El Niño is a hot one. The equatorial trade winds weaken during an El Niño, while they strengthen during La Niña. Increased warm water upwelling from coastal South America toward Asia due to the trade winds causes cold, nutrient-rich water to move closer to the United States. A rise in tropical cyclones is brought on by the influx of warm equatorial water into Asia, which creates wet conditions in contrast to the drought present during El Niño. The jet stream is directed even further north in North America. In the United States, this results in rain in the Pacific Northwest and dryness in the Southwest. The Southwest of the US experienced a mega drought in 2022, which La Niña made worse than it had been in 1,200 years. Now that trade winds and jet streams have been discussed, you may be asking how La Niña affects hurricane season. The news is either good or bad depending on where you live. Because of the increased atmospheric instability in the South Atlantic caused by the change in the jet stream, the Atlantic frequently experiences a significantly more intense hurricane season. However, the Pacific Basin experiences fewer storms than the Atlantic Basin, illustrating how radically varied these geographical effects can be. Contrary to La Niña, El Niño has the opposite impact. During La Niña, the weather in Peru and Chile turns colder and drier, occasionally resulting in severe spells of drought, so you won't see balmy Christmastime seas that previously led fishermen to call it El Niño de la Navidad. On the other side, from December to February, the north of Brazil becomes more humid, and catastrophic flooding can occur in Bolivia's lowlands. In general, the climate in Africa is different during La Niña years than it is during El Niño years. Conditions in East Africa are often drier than average, while those in the south are typically wet. NOAA forecasts. La Niña, which lasted for more than 1.5 years, has officially ended, according to the National Oceanic and Atmospheric Administration. They came to this conclusion by measuring the Equatorial Southern Oscillation Index, or EQSOI, which is a metric used to compare the surface atmospheric pressure in the western and eastern Pacific. The most recent EQSOI value was just 0.1, down from 1 a year ago, indicating that things are now almost back to normal. Although it's too soon to make any firm predictions, there are already signs that El Niño will arrive by autumn, according to the NOAA. This would have far-reaching effects. India has already started to issue drought warnings to its residents. El Niño in 2024. El Niño in 2024 will only be predicted using historical data. There has never been an El Niño occurrence without one since the 1950s when tracking began. The first 5-year period without one would start in 2024 if there isn't one. Studying climatic cycles can aid in human survival not just on our planet, but possibly on other planets as well. The level of understanding obtained about Earth's intricate climate processes because of the ENSOL is one of its most fascinating features. If we ever wish to colonize other planets or even terraform them, we will need to understand how the Earth's climate is interconnected. Understanding the various inputs and feedback loops that intricately connect climate systems and biospheres will likely be crucial to our success if humans ever attempt to terraform Mars, Mercury, Venus, or the Moon, or perhaps even an exoplanet in another region of the Milky Way galaxy. Although the ENSO cycle has the potential to be extremely harmful to both animal and human populations on our planet, life is nothing if not adaptable. A new chapter in the increasing amount of information regarding these events will be added in 2024. If you have any thoughts on the ideas discussed in this video, please leave a comment below. If you enjoyed this content and would like to see more on space exploration and humankind, please consider liking this video and becoming a subscriber for more videos on Beyond Thinking. Thank you and have a Beyond